The other ones were just kind of review, but there are questions going back to the mathematical review. Okay? You have a question?
Yeah, I don't understand, you know, like, extra problems that you put.
Extra problems.
Are they huge conversions and then efficiency problems?
Extra problems, like these ones down here?
Yeah.
All right. Yeah, there's three there. There's a mathematical review on introduction and so which any particular problem?
Yeah, number 2 in the unit problem 2.
Problem 2, number 2.
No.
Okay, which problem are we talking about? Which one of these problem sets?
Question 7.
Which problem? 1, 2, or 3? Which problem set?
Problem set 2.
Problem set 2, number 7. This one right here, a rising bubble of air. That's not a unit conversion one, I don't think.
Maybe it's number 1.
Problem set 1, number 7. A tissue cross section, that one?
Yeah.
Okay, that's the one. Okay, let's have a look at this problem. Sure. A tissue cross section viewed under on microscope shows a cell of almost rectangular shape. Okay, with dimensions this by this. Calculate the cross section of the cell. Express the area in powers of 10. Scientific notation. Use the appropriate sig figs. Okay. All right, sure. Let's try this board. I'm just going to say area equals length times width. Everyone's okay with that? And they give 2 dimensions. 6.9 times 10 to the minus 4 centimeters. And 1.1 times 10 to the minus 3 centimeters. And we're going to multiply that together. And what units are we going to get? We're going to get centimeters squared. Hey, let's go meter squared too, just for fun. I'm not going to do that in my head, believe it or not. Okay. Okay, I multiply that together. Ooh, it's a really crappy calculator. I get 7.6. I'm going to go with 2 sig figs. I got 2 there, 2 there, so 2 seems kind of reasonable. Times 10 to the minus, oh, I got to count with this calculator. Minus 3, minus 7. Is that right?
Yeah.
We're good, thank you. Hard to read this thing. Yes, what's your question? That's okay, go ahead.
The gases problem set. So it's going to be unit.
Oh, no, we're done this one?
Yeah.
Okay, I'm just going to convert this to meters squared because I'm a screwball. Just a second. Okay. Okay. Because I'm a stickler for MKS. Now, if we wanted to make it meters squared, what would we do? Okay. We had centimeters squared here. Okay. So 1 meter. Oh, that's not right. Like that, right?
No, you should square it.
Ah, you gotta square it, right. Centimeter squared, centimeter, it's gonna cancel, I'll get meters squared. Now I got 10 to the minus 7. I'm dividing by, when I square 100, I'm gonna get 10 to the 4th, so what power of 10 should I get? Negative 11 meters squared. Okay, I think that's right. Okay, so yes, there's some unit conversions. Yeah, meters squared, that's fine. There's MKS. I thought these ones had answers. Don't they have answers, or they're just hard to understand? A little bit? Okay. These problems do have answers. Let's go over here for the next problem. Number 8 on this problem set. Uncertainty problems. Okay, so we got A, B, and C. Oh, wait, it's a really long problem. Okay, all right. Are we gonna do A, B, C, and D, or which one of those are we gonna do? All of them. Okay. We gotta do this, do we? All right. AB plus AC. Oh, this doesn't look like fun.
Just takes time.
Takes time. Now, when I'm doing these, what I usually do is I just find the answer first. Forget about the uncertainty. Find the answer first. What do you think? Is that a good plan?
Yeah.
All right. Then going 0 meters, what that was B 20 meters plus what is C 30 meters. Okay, that's pretty easy to remember. So that's 200 plus 300, so I'm gonna get 500 meters squared, is that right? That's the W part, no plus or minus yet. That's where all the work comes in, right? Well, I don't think I'm gonna do all 4 of these, am I? That seems like crazy. Okay. Yeah. All right. So we've got the value of W. Just correct me if I make a mistake here, guys. And again, there are answers to these at the bottom, right? Okay, so we got a whole bunch of different operators going on. Here we have multiplication, and then addition. Okay, when we have multiplication, what do we do with the uncertainties? Change colors. Add the percentages, thank you. Okay, what is the percentage in A? 1 divided by 10 is? 10%. What's the percentage in B? 1 divided by 20 is? 5%. So what's the uncertainty in this first number? 10 plus 5 equals? Come on now. Are you guys okay with that? That's W. A times B equals 200 square meters. 10%, 5%, plus or minus 15%. All right, now we gotta do the AC term. Plus. Well, that's gonna be 300 meters squared, plus or minus. Again, we have 10%. What is the percent uncertainty in C? Oh, is that like 6.7? 7%? 10% plus 7% equals 17%. Okay, that's the multiplication bit. We add percentages. Now we have to add them. What do we do when we have to add or subtract things? How do we handle the uncertainties? We add absolute uncertainties, right? So I've got to find this. What's 15% of 200? 30? All right, that's the first term. That's A times B. Now the second term. What's 17% of 300? That's going to be, what, 30? Is it 45? What is it? Oh, you guys aren't helping at all.
51.
51. Thank you. Okay. All right, so here is A times B expressed with absolute. There's A times C expressed with absolute. And now we add them together. 200 plus 300, we already know is 500. What do we do with those two numbers? Add them. I like that answer. There's the final answer to AB plus AC. Okay? Yeah, I don't think I'm going to do all 4 of those. All right, maybe we'll just start with 1. There should be answers to those on, if you scroll down, have a look. Sorry, that's kind of an easy one, I guess. There's some two terms again. We've got multiplication and division. We're going to add percentages, okay, and then add them to those. Yeah. Question at the back. Oh,
Yeah, problem set.
oh, we're going to go to a different problem set? Okay. Any more questions on this problem set? Let's go to a gases problem set. Which is the gases problem set breakdown? Is it one of these? Number 2? Gases. Okay, this must be it. Question number 3 and 4. Okay, a person can cause a negative pressure of negative 70 millimeters of mercury by a strong inspiratory effort. How far could he suck water up a straw? Oh, that's kind of a cool question, isn't it? You guys don't care, right? Okay, what we're doing here is we're converting millimeters of mercury basically to centimeters of water. That's what this question's all about. Okay, you can convert them both to pascals if you want and do it that way. That's fine. Okay, that makes sense too. But that's basically we're converting from one pressure unit to another. Okay.
So how would you know if it's just asking for you to change the units and not like full of
How would you know if it's just asking you to change the units? It's actually asking a question. Okay, but it's what we're gonna end up doing is finding out what height of water column has the same pressure as that height of mercury column. That's what the question is.
I thought that you could use like an equation and find the height, but you just convert it.
You could just convert it. Well, let's use an equation, okay? First of all, let's start off with negative 70 millimeters of mercury. It's always good to practice converting, right? And we're going to convert that to pascals. Is that okay? I think there is a direct conversion between 1 millimeter of mercury and pascals somewhere on the formula sheet. 133. Does that sound familiar? There's our conversion factor. Is that one right? Looks good. We're getting rid of those millimeters of mercury. Okay, so our vacuum is negative gauge pressure. It's below atmospheric. 70 times that. I don't know what that is. Kill. Let's try this. 70 times 133. Is that okay? I'm just converting it to pascals. Okay? Yeah.
So like, if you were to get a question like that on the test, I would expect it to be like convert this to this. How we can like decipher in the question whether it's saying all you need to do is convert or you need to
Okay.
figure out.
That's this next part of the question. Okay, we'll try to do that now. Okay, so this person's lungs can provide that much vacuum, right? Millimeters of mercury or pascal, same unit, right? And now they're sucking water up a straw. All right, let's have them do that. Here's where we're adding in the equation bit.
Ooh, yeah, okay.
Okay, you guys sucking on a straw. Come on. Honestly, it is, right? Okay.
Honest, it's a straw.
And he can suck it up the straw so high? H, that's what we're being asked. How far can this person suck the water up the straw? Okay, we know they can produce that much vacuum. So, atmospheric pressure there. That vacuum plus that height equals atmospheric pressure. Are we okay with that? Right. So what we want is our rho GH basically to equal this number right here. Is that the best way of doing it? So,
Atmospheric pressures.
not forget this. I'm putting numbers in like that. Okay, now it's not going to be a negative height, it's going to be a positive height, but whatever. Okay, I've got I can produce 9,310 pascals of vacuum. Okay, I got G, that's 9.8. I've got the density of the fluid, it's filled with water, right? Where's the question?
Gatorade.
3, yeah. It's sucking water up a pipe, right? Yeah, water. Okay, it's not ethanol or something like that. So that's the density. Okay, and what's that? 9.3 divided by 0.98. 0. What? 0.95. And what are the units? Pascals, meters per second squared, kilograms per meter. We're going to get height in meters. .95 centimeters. This person can suck water up a straw 95 centimeters. Yes?
Could you just, like, instead of converting to pascals, convert it to
Directly from millimeters of mercury to centimeters of water. Yeah, that's what you'd still get the same value. But we're asked what are we actually doing here? Okay, this guy's got a little negative pressure, so he's got an extra rho GH, okay, to match atmospheric. I think that's what the question was. Okay, why are we doing this, or where does the equation come from, or something?
Can you do number 4?
Yeah, just a second, I'm gonna ask over here, you got a question? Or you're just playing with your hair? Oh, we got a question down here on the floor, just a second, yeah.
Okay, will you give us like what you want advanced units or sections?
Will I give you what you want? No, but I'll remind you to include units. A lot of people forgot to include units on their quiz. Okay, your final answer should have some units.
No, but like you would say.
Well, he was asking.
Give me the final answer in pascals. Not necessarily. Depends on the question. Okay. Okay. Question back there. If you, no, as long as you make a clear statement at the end with units and an appropriate number of sig figs, that's always good. Some people underline them or box them. That makes it easy to, oh, this is the person's final answer. This is what they want me to look at. That helps too. Yes. Yeah, let's have one more here, then we'll go back to the midterm. I think I opened that a while ago. We never got to it. Okay. All right, number 4. An oxygen cylinder has a gauge pressure of 2200 psi. Is it okay if I say psi? At 27 degrees Celsius. What would be its gauge pressure if the cylinder is heated to 77? So this is one of those gas law style problems, right? Okay, so we're going from one pressure, volume, and temperature to another pressure, volume, and temperature, right? And I think I'm just going to leave the units in PSI. Is everyone cool with that? Is the final answer in PSI on the answer sheet? Or at the bottom? Pardon me? I don't know, let's scroll down that one and check and see if I'm right. So this incorporates all three of those gas laws, right? Boyle's, Charles, Gay-Lussac's. And in this one, the volume stays constant, so V1 equals V2. Those cancel off. Everybody's okay with that? And we're trying to find P2, is that correct? So I'm gonna rearrange for P2, P1, T2 over T1. And then I'm gonna put some numbers in. 2200 PSI. T2, what is T2? The second temperature is, which one are we on? Number 5, right? Oh, I'm doing the wrong problem? I think I'm doing number 5, sorry.
Might
Oh,
as
I'm doing
well.
the wrong one, sorry. Yeah, all right, let's finish number 5 since we started it. 77 degrees Celsius, would you put 77 degrees Celsius there? No, what do you put?
Kelvin.
How many Kelvin? 350? That's 273 plus 77. 350 Kelvin. Initial temperature is 27. Oh, so that must be 300 Kelvin, right? Oh, not 3,500, 350.
That'd be kind of old.
Like that. Does that look right? Final temperature in Kelvin, initial temperature in Kelvin, okay? Initial pressure, so the pressure is gonna go up. So I multiply that through, so I'm timesing by 7 and dividing by 6. Can I do that in my head? No, it doesn't work out that way. 2,500 and what? 66, close enough.
Well, 67.
67, whatever. Okay. There we go.
What is that in kilopascal?
Look at number 4. The gauge pressure of automobile tire is 30 psi. If the volume of the tire is 1 square foot, how many cubic feet of air at atmospheric pressure had to be compressed to fill that tire? Is that what we're looking at? Okay, this is sort of simple. Yeah, we'll do this one and then we'll get to the midterm. Sorry. This is again just like one of these. We got two situations. We got the inflated tire and we have the air before it goes into the inflated tire. You can make either one of them state 1, state 2, doesn't matter. What stays constant in this question? Number 4. The temperature. We're assuming that the tire isn't changing temperature. So I can cancel off the denominator. Is that okay? And all right, I'll make this P1. What's the first pressure? 30 psi. Let's stick with good old psi. The first volume is 1 cubic foot. Okay, oh, I guess we need to put these in absolute, don't we? Yes, yes, yes. That will work, otherwise I'll have like a 0 here. That'll make the equation really hard to solve. 30 psi. Well, what is standard atmospheric pressure in psi? 14.7. So what is the absolute pressure inside the inflated tire? 30 plus 44.7, right? Maybe I'll double that. 30 PSI plus 14.7 PSI. We need to use the absolute pressures, yes.
How to pick up 14.7 PSI?
14.7?
Yeah, how do we get that?
1 standard atmosphere equals 14.7 psi equals 101.3 kilopascals equals 760 millimeters of mercury. Right, so so our tires are 30 psi above that, and we need to use absolute pressure into this equation. Yes.
Why do we add them?
Why do we add them? Because it's positive gauge pressure.
No, I mean, like, why are we adding them?
I need to know the absolute pressure inside the tire. 30 psi is not the absolute pressure, that is the gauge pressure. That's how much higher than atmospheric pressure the pressure is in your tire. You pump them up to 30 psi, they're 30 psi higher than atmospheric. So the actual pressure inside the tire, absolute, is 44.7. That's the number I want to use in this equation. I've got the initial volume, okay. The second half,
Is
atmospheric pressure, so over here, 14.7 psi, and
pounds per square inch is the same as PSI?
are unknown. It's called V2. What's that, Gord? You're laughing about something. It's not-
Pounds per square inch
It's
is
not-
PSI.
Yes, it's not
Yes,
the laugh of a
of course.
maniac, is it? It's all good? Okay,
Stupid.
Okay.
Yeah.
just a second here.
I'm looking for the conversion
V2.
factor.
So I'm just gonna put the numbers in here.
Yeah, there you go.
44.7 psi, 1 square foot divided by 14.7 psi. And psi is just short for pound per square foot. Oh, yes, it's cubic, not feet squared. Cubic feet, it's a volume. All right, so the psi disappear, we're left with cubic feet. It looks like around 3. Is it exactly 3.0? All right, 3.0. Cubic feet. So we had to take 3 cubic feet of air and stuff it under pressure into the tire to get it to pump up. All right, that sounds reasonable. All right, we're going to go to the midterm because people have asked questions about the midterm, the practice midterm. I think we had this up before. Again, there's multiple choice. There's a couple problems. Any particular one you guys want to have looked at? Do them all. Just do them all. I'm not doing the first one. I'm not doing the sentence answer thing. Do them all. Why don't I just include answers? Is that what you're saying?
Yes.
We're gonna have to do them again. I kept it answered a week ago. This was like years ago. No, I'm gonna get you guys to answer them. All right. The sphere has a volume of V naught. If the diameter of the sphere is double, the new volume is. What is the formula for the volume of a sphere in terms of its diameter? Volume equals what?
Pi d.
Good old pi. You gotta have some pi. Okay, is everyone okay with that? That is the volume of a sphere. All right, so we're not changing this bit, we're making that twice as big. So basically we got a 2 to the 3 in there. Okay, what's the correct answer? Doubling the diameter, so the volume is going up by a factor of 8. The answer is E. Okay. Put a 2D if there if you like, but you're cubing the 2, so it's going up by a factor of 8. All right, question 2. A rectangular bat. Oh, this is just a unit conversion. You guys can do that, right? Okay. I don't know what the correct answer is. 48 by 3.6. It should be bigger than 1, just bigger than 1. It's either going to be B or C, I think. Its answer is B. Okay, I like B. 3, A, B, and C. Oh, sorry, you got A, you got B, C. So this is another sort of handling uncertainty type question. The operation is C.
Add
C is A
relative.
divided by B. So what sort of uncertainties are you going to use? You're going to have to find percent uncertainties, and then you're going to add those percent uncertainties together, right? And then find that percentage of C. Should we try that once to make sure we get the right answer? Sure, just for fun. Forget that uncertainty stuff first of all. What the heck is A divided by B? 18.4 divided by 3.8, yeah, well, 4.8 obviously, they give all the same answers, so 4.8. I just get the answers first and the units. A is in meters and B is in seconds. It's some kind of speed or velocity, is that right?
Yes.
Well, that doesn't help too much because all of the answers have that same information. We better go on a little bit. Okay.
Show your work.
What's the percentage in A? What's the percentage in A?
3.2.
0.6 divided by 18.4 equals how many percent? 3.26? I'm going to call it 3.3%. Is everybody okay with that so far?
Yeah.
What about B? Point 0.6 divided by 3.8. What's the percentage again? Sorry? 15.8. So if the percentage of this one, 0.6 divided by 8.4, 3.3%. Okay, this one will have a larger percentage, 0.6 divided by 3.8, 15.8. Now I'm going to add those percents together, 19.1. How's my math? Okay, all I have to do is find 19.1% of C. So C equals 4.8 plus or minus, what's that times 0.2? Is it 0.9? I think the answer is going to be C. Something like that. It's okay. It was division, so I have to find percent uncertainties, add percents together, get a total percent. I get a total of this percent, I times that by this to give me my absolute. I guess the answer was C. All right, 4 and 5, a couple more should we go through these? Everybody want to see the answers to 4 and 5? There are some people who do. There are some people that do. All right. Okay. All right, first of all, it says the daily atmospheric pressure is 98.5. That's measured with the barometer. The flask has a pressure of negative 21 millimeters of mercury. So the pressure is going to be what? Above or below 98.5? It has to be below. It's a negative gauge pressure, so it's below atmospheric pressure. So obviously, looks like answer C is out the window. All right? Question is, how much below? It's a matter of converting that millimeters of mercury into kilopascals and then taking it away from atmospheric pressure. We have to find the absolute pressure. Is that what we have to find? All right. I have an equation for that. I think this is on the formula sheet, right? Is that one on the formula sheet? Something like that?
Mm-hmm.
Okay. Let's put the stuff in. All right, 98.5 kilopascals. All right, has to be a positive number. atmospheric pressure does. Can't have a negative atmospheric pressure, that'd be very strange. Minus 121. Now, obviously, you're not going to subtract that number from that number, right? They're in different units. And the final answers are all in kilopascals, so that's what we want. So we need to convert this. And we just talked about this, I think. 133 pascals, 1 millimeter mercury, like that. And that conversion factor is on there. That one will work. Okay. Write this out a little bit. 98.5 kilopascals minus 121 times 133. 16,093. What are the units I'm going to have here?
Pascal.
Pascals. Now again, I see this happen many times in exams. Do not subtract pascals from kilopascals. Okay? This number is probably better written as 16 kilopascals. That many kilopascals minus that many kilopascals, the units are the same. Now you can go and do the subtraction. So, what is that going to be? 8. Oh, you're calling that 16.1, 18.4? Is that one of the answers?
Yeah.
82.4, is that on there?
B.
It's B, yes, it's B. Okay. Finally, there's one on a gas. Okay, this looks like one that uses one of the two gas laws. Should we do this one?
Yeah.
So yes. You guys got nothing better to do?
This is what I'm doing today.
This is what you're doing. That's okay. Hopefully it's time well spent. Okay, this particular one has numbers of molecules. So I'm going to use the gas equation that uses numbers of molecules. Remember, there's two different versions. That's the one I'm going to use. We don't have moles here, so I'm using the one with capital N, which is number of molecules. And I'm solving for the temperature. So, PV over N KB. I think my math's okay. Now we have to be very sure that everything goes in terms of MKS units. That constant is in MKS units, so we got to have MKS all around. Let's have a look. That's where maybe the tricky part comes in. The pressure is 180 kilopascals. Is that MKS?
No.
No, it's not. It's close, but not quite. It's got to be in pascals. The volume is 2.55 liters. Is that MKS? No, it's not. Can you guys convert in your head? Got to be in meters cubed. You have to divide it by 1,000. Okay? Here's something I should also tell you guys. When you look at multiple choice questions, they're all worth 2 marks. But some of them are more difficult than others. Okay, expect that. Some multiple choices, that one's pretty easy, other ones are tougher, but they're all worth 2 marks. Don't assume that they're of equal difficulty. This one, it's got a whole bunch of little tricks and traps built into it. N, we got N, right? It is 4.78 to 10 to 22. And there are no units there. It's just a number of gas molecules. KB, there's a constant. 1.38 times 10 to the minus, I'm running out of space, 23 joules per Kelvin. Okay. And we're going to get a number there. Remember that 1 Pascal times 1 meter cubed equals 1 joule. It's a unit of energy. We've got 1 over kelvins on the bottom coming up, so we will get a temperature in Kelvin. Something in Kelvin. Does anybody have a number? I'm hearing a whole bunch of different numbers. That's not a good sign. Two, 5 divided by minus 22 divided by 1.38 exponent. Oh, I blew it already. Minus 23. Oh, nuts. This is going to be totally wrong. Okay. Just a second. What is it?
696.
696. Sorry, guys. I put negative 22 in there, so I got to start all over again. Does everybody agree with that number? Okay. You'll notice that that is one of the responses in degrees Celsius. So some people probably picked that. That is the wrong number. The answer is not D. Those temperatures are all in Celsius degrees. So how do I get that into Celsius? What do I got to do? Subtract 273. 6 minus 3 is 3. 9 minus 7 is 2. 6 minus 2 is there something like that, one of the answers?
Yeah.
The answer is C. Wow, that's a tricky one. Okay, pressure's got to be in pascals, volume in cubic meters. Okay, temperature comes out in Kelvin, and then finally you got to convert it back to Celsius. Lots of little tricks to do on that question. So yeah, the multiple choice, that one's probably the most difficult. There's so many little ways you can go wrong. Everyone's good with that? Any more questions? Yes. Could I do them? Yes. Should I?
Yeah.
Gotcha. Sure. All right. First of all, let's have a look at this one. It's a double U-tube manometer. All right, so there's pressure A, there's pressure B, and then the sides open up to the atmosphere. By the way, is PB above or below atmospheric pressure? Above. Why'd you say that?
Heights of the column.
We got atmospheric pressure over here. Okay, PB there. You compare the two with a manometer. Is PB higher or lower than atmospheric? It is higher because higher pressure here has pushed the fluid up on the other side. That's just one way of looking at it, okay? So when we find the pressure there, do we have atmospheric? We do. It's going to be higher than 97.5. What about PA? How about PA and PB? Which one of those is bigger? PA or PB? PA. Again, for the same reason. We got another manometer here, comparing the two. Pressure A is pushing the fluid up on the side of pressure B. That pressure has got to be stronger than that one. Okay, so PA is the biggest, then PB, and then atmospheric pressure. So both of those are going to be numbers above that. Everyone's okay with that? All right. So you're not going to be able to solve for PA right away. You're going to have to solve for PB and then get PA. Does everyone see why that is? I'm not going to write an equation for PA, but it'll have a couple of unknowns in it. It'll have PB in it. We don't know that one yet. All right. Maybe I'll do that after. Let's do PB first. It's a U-tube and they're filled with mercury. Okay, and we have some values of H. Yes, we do. So again, we're looking at this manometer here on the right, and I'm comparing the pressure right there, okay, at the bottom of the PB air, if you like, and that pressure right there. Those two pressures are the same. So my equation for that part is PB, because that's all I have on the left-hand side. I got pressure B pushing down right there. Oh, I forgot to take out the little tab right there. I think that was word. It was really hard to do the start things. On the other side, what do we have? Well, we've got atmospheric plus rho GH, right? Okay, so yeah, PB is higher than atmospheric by that amount. All right, let's quickly find out what it is. 97.5 kilopascals from the barometer. Okay, rho GH, what's rho? 13,600, right, it's a really dense fluid. What's G? 9.8. What's H? Got to put it in meters. Neglected to use for a second because I'm running out of space. Okay, but I got kilograms per meter cubed, meters per second squared, meters. And plus, how many pascals is that? It's gonna be a whole bunch, right? 13600 times 9.8 times 0.169 22524, is that right? 22524. Now again, do not add pascals to kilopascals. Careful, careful. Now I can add them together. Okay, that'll give me PB. All right, you guys finish that? Let's do the other one. Okay, so now we know the pressure in there. We're going to find the pressure in there. And again, we're going to look at that point in the fluid. On one side we got PA, on the other side we got PB plus rho GH. Similar sort of equation. Okay, so you're going to get PB from the first part, same density, same G, and now the H is 0.114. All right, we're at the kilopascals, add them together, that'll give you PA. Yeah, so they're both above atmospheric. PB is 22.5 kilopascals above it. PA is even more, okay, because it's higher than PB. It's just a matter of putting the numbers in and doing some addition. All right, everyone's good with that? Are we all done? One more. What else do we have to do? The next one, are you sure? Wasn't there one like this on the problem set? All right, we got a cube. All right, it's a big chunk of brass. Now, normally if you drop brass into a lake, it will sink. However, we have an additional force provided by a cable or a string or a rope holding it suspended. People seem to have a hard time with this. The problem is that some people have that little rope at the bottom pushing the block up. Okay? Rope generally can't do that. Find the weight of the brass cube. You guys can do that, right? Okay. Find the buoyant force. You guys can do that, right? And then there's part 3, the apparent weight. So let's just do part A first. The weight of something is what?
Mass times gravity.
The mass, I guess I should call it the brass, or the mass of the brass times G. Okay, do we know the mass? No, but we do know right? You can find its weight, and remember, it's in what units? Force, it'll be in newtons. Good, all right, there's part A. What's part B? The buoyant force. Oh my, how are we going to calculate that? The block is immersed in a fluid, so there's a buoyant force equal to the same kind of thing. Mass of the displaced fluid times G. So density of the displaced fluid, volume. Well, the volume of the displaced fluid is the same as the volume of the brass cube. Is everybody okay with that? I'll just call it VB. Again, if I multiply those two, I'll get a value of force in newtons. Okay. The density of the fluid times the volume of the cube, or the brass, because that's the amount of liquid that's been pushed out of the way, okay, times G gives you its weight. Everybody's okay with this so far? The last one is the tension in the string. Well, let's have a look at this block. There's actually 3 forces acting on it. Okay, what are the 3 forces? The weight of the block is acting which direction? Weights tend to do that. The buoyant force is acting which direction? Up. Yeah, buoyancy holds you up. And there's a third force by the cable. You could call it force cable, force tension. What direction does that act? Okay, yes, ropes, cables tend to pull. And that's how you're going to do part C. Okay? You know this one from part A, you know that one from part B, you're going to find FT. If you want to write a little equation, you got 2 up. FT equals FW. Moving the other one to the other side, bingo. Okay, I'll let you guys put the numbers in and finish that. Okay, that is the practice midterm. Couple of problem sets. Anything else? Question right there. Problem set 2, number 8. Like these problem sets? Like the quiz? Quiz 2, number 8. Oh, down below. Is it this one right here? Some pearl divers regularly dive to depths of 25 meters. If a diver fills his lungs with 6 liters of air at the surface, what would be the volume of air at 25 meters in depth? Fair enough. Kind of a 2-part question. Is that good enough for now? You gotta go. Some people have another class at whatever. When's that communications class? It starts at what time?
Oh yeah, right now.
Starts at 1?
1:30. 1?
Starts at 1. You guys have a class starting in half an hour. That's fine.
Fine.
Anyway, we're doing number
Oh,
8.
I just follow people, you know. We haven't canceled it.
Okay, it's actually another one of these. Okay. Okay, so we've got some pressures, volumes. What is staying constant though in question number 8? The temperature. So T1 equals T2, I can cancel that off. Now for the pressures, I have to put in absolute pressures. Okay, do I know the pressure at the surface of the ocean? At sea level, the pressure is approximately what? What units do you guys want to use? KPA?
Thank you.
All right, see you guys tomorrow. All right, so the pressure up there is 101.3 kilopascals, and let's just leave it in liters. Okay? We also need P2 in order to find V2. Now to find P2, okay, we have to take atmospheric pressure and add rho GH to it. The pressure down 25 meters is higher, right? Everyone's okay with that? And it's higher by that amount. Okay? The density of the fluid, G times the height, 25 meters. All right, let's see what it is. 101.3 kPa plus the density of seawater, they give you a slightly different density. 9.8 and 25. I don't know what that is. 30 times 9.8 times. I get 252,000 pascals. Is that right? So this number would be 252 kilopascals. Okay. So what is P2? We have 101.3 due to atmospheric pressure, plus 252 due to the seawater. Add those together. What do I get for P2? I get, I'm going to call it 3, 5 plus 0 is 5, 1 plus 2 is 3. That should work. Okay? So I know P1, I know V1, I know P2, rearrange and find V2, and it'll come out in units of liters. Okay? And it looks like it'll be about 2 liters or something. What's the value they give in the solutions? 1.72.
Thank you very much.
Yeah. Okay. You guys back? Do you have any questions? You okay? Oh, you have a question. What is the equation of the line? So this is quiz 1, number 6. Let me put that up, okay? So I can see what's going on. Quiz 1, number 6. Oh, it doesn't show it real well, does it? Can I preview the question? There must be a way to do it.
Thank you.
Right here, yeah. See you guys tomorrow. See if I can get it all on the same screen is what I'm trying to do. This is the right one? Okay, so it's a straight line, and the general form of a straight line is...
I'm so far behind. You want one? 2.4.
y equals mx plus b, right? We just got to put the things in.
Oh, I didn't have.
Yes. See you guys tomorrow. So what's on the y-axis? Mass of rhubarb, right? abbreviate for a second. We need to put in the slope. All right, now that will be a number with some units. And it'll also be a negative number because the slope is in that direction, right? So it should be a negative slope. So I have to pick a couple of points. Rise over run is, oh, here's a good point. 40 right there, and this one down here. So the rise is 60. The run is 25. What's 60 divided by 25? Is that 2.4? 2.4. And I gotta have the units in, which is the Y units, kilograms. The X unit, centimeters. So there's my slope. Okay, now for X, that's just what's on its length of stems. That's all you gotta put in, length of stems. Okay, so Y, M, X. Let's have B, that is the intercept. Okay, and it looks like it hits the Y-axis with a positive intercept of about, I don't know, 52 or something like that. So positive 52, and it has units, same units as the other ones on the Y-axis because it's a Y-intercept.
Which ones did you use to get the 0.24 again, sorry?
I used that point right there and that point right there.
Okay.
So I'm going up 20 plus 40, so I'm going 60 overall and 25 in that direction.
Okay.
And I think it's 2.4. So is there an answer that looks something like that
Yeah.
on
Yeah, that's right.
which one is it? It's massive rhubarb, negative 2.4. It looks like the very one at the very bottom.
Yeah.
But they're scrambled, so you guys would be different. So here is the answer I would select right there.
So
Yes.
You say 24 is from, can you say again the 25?
How did I get that slope?
Yeah.
All right, I'm taking these 2 points. Okay, what's the change in Y?
What is the change?
Right, rise over run is how you get slope. Okay, so if I'm going from here up to there, how much am I going up in the Y direction?
60.
60 kilograms, right. Okay, how much am I changing in the X direction? Going from there over to here. 25.
Yeah.
Right. That's exactly how I got that number right there. 60 divided by 25 is 2.4.
But how did you decided the 2 points?
Why did I pick those two?
Yeah.
You can pick any two you like. I just like these because they
Good numbers.
directly cross the major grid points. I could pick these two if you want. Okay? It's a little tougher because that one's, you're kind of guessing where it is. I just picked those two because they're right on the intersections.
And are you cutting us off right after class for the test, or is there a bit of wiggle room?
I will try to give you as much time as we can. But if some people come in, oh, we have a midterm starting in 2 minutes, we're gonna have to get out of the room.
Yeah.
I'm
Okay.
not sure how it's gonna go. I will be there early.
Okay, so if I wanted to start earlier, I could.
I will be there, I'll try to be there early. If people are all sitting down, ready to go, we'll handle the exams as soon as we can.
And
Okay.
then, how many questions is it?
Similar to what's on the practice midterm. Should have that same format.
Okay, thank you.
All right, we'll see you tomorrow.
Yeah, thanks for doing
Okay,
this.
yeah, I hope this helps, guys.
So the 52 is from that point?
52. I'm just seeing right where it crosses right there.
Oh,
I'm guessing it's 52. It could be 53.
okay.
Okay, but that's my best guess.
So this way is negative, this way is.
This is a negative slope. That is a positive slope. Yes, that's right. Yes. Which one are you working on, sorry?
Oh my goodness. 17.
One, 7, 3.